Hi guys, this is part 2 of the polynomial video, and I do want to make this video as quick as possible since you have to watch 2 videos tonight, so I'll go in and get started. The degree of this polynomial is 5. The lead coefficient will be the coefficient of the term that has the biggest degree, and that is 1, a positive 1. Now I want to recall your attention that if we have a positive coefficient, a lead coefficient, and we have a degree of 5, our end behavior will look like this. That's what we can expect the graph to do. And again, we have no idea what goes on in between yet, but we know that the ends on the left and on the right should look like that. The terms. There are 3 terms. The y-intercept, plug in 0 for x. So if I plug in 0 for x, I get 0 to the 5th plus 0 cubed minus 6 times 0, and all this work amounts to nothing, basically. You get 0 for your answer, and I wrote down the coordinate with x being 0 and the y value being 0. The possible zeros is going to be equal to, sorry about that, guys. The possible zeros is going to be equal to the degree of the function, and the degree of the function is 5. It doesn't mean we'll definitely have 5 zeros, but it means that 5 real zeros could possibly exist. For possible extrema. For possible extrema, it's always going to be the degree minus 1. That's going to be 4, as our degree was 5, and we have to subtract from it. For the values of real zeros and the multiplicity, the function was x to the 5th plus x cubed. So in order to find the real zeros, let's go and factor this. I can take an x out of each term. And I notice that what remains on the inside of this parentheses is an even power, and no power, which means I could write this next polynomial as a product of 2 quadratics. I'll put an x squared here for an x to the 4th. And I need a positive 3 and a negative 6. So I'm going to go with the positive 3 here. I'm sorry, I said a negative 6. I need factors of 6 that are going to add up to a positive 1, and we'll multiply together again to get negative 6. And I believe plus 3 and minus 2 will get that job done. Please check this on your own to make sure that when you multiply it back out, you do get the original function. I do want to keep going with this here, so this factors into x times x squared plus 3, and then times x plus the square root of 2, times x minus the square root of 2. And I notice that for the real zeros, I have a x to the 1st, an x to the 1st, and an x to the 1st, and this determines my multiplicity of those real zeros. So it's a multiplicity of 1 for all zeros. And then finally, we already addressed it at the top. Oops. The end behavior looks like that. The end behavior. See, I'm new to this technology, so again, your patience is appreciated. Okay, so we said that the end behavior was this up and down part, and it's going down on the left, up on the right. So the way we translate that into words as x goes to negative infinity, the y value is going to, it looks like it's going down on the left, so that's negative infinity. And as x goes to positive infinity, or as x is going to the right, the y values are going to positive infinity. Please pause the video now to go in and try the next problem. So let's see if you got the right answer. The degree of this function is going to be 4, and the lead coefficient is going to be a positive 5. Now, even degree with the positive coefficient means my end behavior will be pointing up. And it's like, yay, I'm so happy. We'll erase that because that actually has nothing to do with the problem. That was me. No, that wasn't me. That's not true. The number of terms, we have 1, 2, 3, so that's going to be 3 terms. The y-intercept, if I plug in 0 into this function, I'm going to get f of 0 is equal to 10. So my coordinate here is 0, 10. The number of possible zeros, it's going to be the degree, which was 4. The number of possible turns is 3. And we got that from the degree minus 1. The values of the real zeros and the multiplicity of them, we add 5x to the 4th plus 15x squared plus 10, just double checking, which means that if I can take out a 5 out of both terms, actually all 3 rather, I'm going to get x to the 4th plus 3x squared plus 2. Let me double check that. And that does look like it's correct. I notice that my resulting factor is going to have an even degree, and no degree. That's usually a key that this big factor will result in 2 smaller factors. X squared will be the first term of each binomial. And we'll need factors of c, a positive 2, that will add up to 3. And I believe that's going to be a positive 2 and a positive 1. And this is our factored form. Now, if I set each one of these equals 0, and I solve for x, as you might have done, you get plus and minus I root 2 and plus and minus I. But the question is asking for real zeros. So the value of the real zeros is going to be none. There are no real zeros for this polynomial. The multiplicity of each zero will be 1. Now, that was kind of a tricky question with the multiplicity because we are talking about real zeros and there were no real zeros. So if you gave an answer of NA, that would certainly be acceptable for the context of this problem. Finally, the end behavior is, we said that the arms were pointing up, and the way we write that out in words, as x goes to the left, or negative infinity, the y value is going up to positive infinity. For the right side, as x goes to positive infinity, the y value is also going to positive infinity as well because it's going up. Hopefully you got all those correct. If not, please check in with your teacher or ask a friend, Google something. And other than that, thanks for watching.